your attention to, because you might get confused about the kind of 3D that I have to offer. Therefore, I brought a box along to remind you what I learned about 3D when I studied mathematics and computing in Darmstadt in Germany. So, apologies for my German accent despite the Scottish name. But I started my life at CERN in Geneva, where I used to diagnose the problems of physicists who have become Nobel Prize winners. So I have learned to trust my thinking, even though it is out of the box. I describe it as software-aided thinking, and call myself sometimes also a cyber woman. And to qualify the 3D is what I've done, especially for this presentation, because obviously I do not know anything about proteins, so I had to learn to look at proteins, and thanks to Google it is possible. And I discovered that there are lots and lots of software people who produce protein images in millions and one ways, so they revisualize but proteins, whereas I revisualize images. So I'm producing, with my software that currently only sits on my laptop, a visual and metric 3D which is useful for both the human eye as well as software. And that's where I provide just the fundamental infrastructure of thinking and embedding it in software. So the key is the interrelationship of this feedback mechanism between what a digital image presents and how we interpret it, we as people and the software that exists so far as a prototype, but that has lots and lots and lots of possibilities, too many for too many people as well. In terms of revisualizing with my software, I came across this image which presents a cytochrome C protein, which maybe you are all familiar with, and I just was marveling at what came out, because I think anybody would admit that it shows more just visually. But whether that is meaningful or how meaningful it is in terms of what do we see, what are the differences that we can spot, especially when we compare hundreds and thousands and millions of images. That is the key. Digital image, and lo and behold, my software takes anything that is the digital image, so it also shows more of what a software, what biometric piece of software produces. It may not look very sexy, but on this particular reproduction, it looks much better on this screen than on that, I'm afraid. But I'll put it on my blog, and I can send you the presentations as well if you like. This one I really liked, a hen-egg lysozyme, published in Nature. Now, I loved these rings when I saw them. But again, what the key is not for me that they look great, these images, but that they can be compared with each other, that you can not only spot the differences with your eye, but that the software can give you as the end user numbers, values, because they can be compared. Software cannot compare visual effects. That's what the brilliance of the human mind is, and the eye. Here's another example, because the purpose is to deepen analysis of protein analysis. I mean, I cannot deepen that. I offer you a tool, and I'm looking for people who know more about proteins than I do. So this is called an OMPF protein, and I thought what came out was also quite interesting. And that and how my method is different and out of the box, I try to illustrate here by comparing. And here I'm comparing again on another level. If you like, the left column is sort of on the human level, where we move from data to interpretation up to intelligence, whereas in software terms I'm embedding my very generic methods into core processes, eventually as toolboxes, but up the scale, the fact that software can associate numbers with images leads to user-friendliness via web portals that can address many different kind of application areas, and within protein analysis, different special areas as well. Comparing visually and quantifying numerically. And that's these are the two new aspects of 3D that I'd like to present to you. The visual aspect always gets what in German is called the Gestalt, the whole impression of an image, the pattern. But the software can do both. Get a kind of an indicator for a whole image as well as go into the analysis. I haven't done the coding for that, but I have done the design. I call myself a software designer. I'm not a programmer anymore, but I know enough about the mechanics, if you like, of computers, and I've learned to think as logically as a computer, that I have produced a software that works. And my colleague who wrote her PhD on an expert system gave me this quote because she appreciates what we can produce. Deepening protein analysis by measuring on screen, I'm therefore suggesting that we can quantify by working together and collaborating to compete, as I just saw on one poster, the characteristics that are, if you like, qualitative measures. That I remember one of the first of these kinds of events that I went to, somebody said, how do you measure porosities? Well, I can do it, and homogeneity and all of these complicated words. Well, I've developed a whole glossary of such measures already. In mathematical terms, they are ready to be translated into whatever specialty area of science they need to be used for, and I've got a great vocabulary specialist for that too. So we can compare images, and interestingly enough, not only microscopic but also telescopic images. And my particular interest lies in finding which imaging technology will be the best for which application, because different instruments distort in different ways. That's what I've discovered so far. And I'm sorry I'm not the master of the speed of this delivery, but thank you for your attention. And I hope I was in time for lunch.